Okay, so here we go. I got on my board. We are recording Friday, March 20th. We're going to do systems of equations where you have to do a little bit of multiplication, sometimes to one or two equation to make it work. So we're going to take the very first one. The system is 5x minus 2y equals 4, and 3x plus y equals 9. So this is a system. This means we have two equations that we want to find a solution that would work for both of the equations, the same numbers that would end up working for both the equations. So to do that, we can do a process called elimination, which means we want to get rid of, annihilate, zero out either the x's or the y's. And we want to try to see, can we get rid of, which one can we get rid of, can we zero out, can we annihilate, that would be the easiest to get rid of. In this case, we see that we have a negative or a minus 2y in our first equation and a plus y in our second equation, and we go, oh, well, I could build up this plus y to a 2y, and then that plus y and the negative 2y, they would zero out. So how could I do that? Well, I have to multiply my y by 2. Well, I can't just multiply the y by 2. I got to multiply the whole equation by 2 to keep it balanced, because the good old saying, whatever you do to one side, you got to do to the other side, when you were doing our algebra, we can build up anything as long as we build it all up to be equivalent. It's like doing our fractions. When we make a common denominator, we have to build up that denominator and build up the numerator so it keeps equivalent. Well, we're going to do that to this equation. We're going to multiply the whole thing by a 2. So I put a parenthesis around my entire equation to show that I'm multiplying the entire equation by a 2 in order to build that y up to where we need it. So we're going to distribute that 2 to everything on the inside of that parenthesis. We're building up all the terms of our equation. So 2 times 3x is 6x. 2 times plus y is plus 2y. And 2 times 9 is 18. So I just built up this equation on purpose so that I could annihilate that minus 2y of my first equation. Now it's kind of messy like this, so what you might want to do is either cross that out, or if that gets too messy, go ahead and rewrite that first equation down below your built-up equation. It's okay to move them. It's no big deal to move them around. And then you don't have to look at that first set of stuff. And you might even want to cover it up with a piece of paper or erase it if it bothers you to look at it. Okay, so we're going to draw a line under our two equations. And we know we want to combine them because if we combine a positive 2y and a minus 2y, those things are going to zero out, aren't they? If you have two positives and two negatives, one for one, bink, bink, done, right? We have 0. So that means when we combine, that means we're going to add these equations together. So 6x plus 5x is 11x. Positive 2y plus negative 2y, ding, ding, that's just a 0, isn't it? So we don't even need it. It zeroes out. So we're able to just go, boom, you're gone, annihilate it. And that's going to equal, okay, 18 plus 4, which is 22. Now this should start to look comfortable, hopefully, and familiar. If you have 11x equals 22, we want to get x by itself. 11 is multiplying x. To undo multiplication, we're going to do division. So we're going to do whatever we do to one side, we got to do to the other side, right? That's our equal sign, so we're going to divide by 11. 11 divided by 11, that becomes a 1. 1 times x is x. And 22 divided by 11 is 2. Now, all that work, and you're probably thinking, whew, okay, I did it, I'm done. Oh, darn it. Not quite. This is one piece of the solution. This is our x value. X has to equal 2. Now we need to go back and substitute in. That's a fancy math word for plug it in, right? Plug in this 2 for an x. Now we can choose either one of the equations to plug that 2 into. You could plug it into the 5x minus 2y equals 4. You could plug it into your original 3x plus y equals 9. Or you can plug it into the 6x plus 2y equals 18. If you plug that into any one of those equations, you're going to get your y value. So if you want to think smarter, the easier one to do is that second one, because notice nothing's going on with the y. So if we just plug the 2 in for the x, we're going to be able to solve for y pretty quickly. So let's go ahead and do that. Let's take the 3x plus y equals 9 and plug in that 2 for our x value, right? That x equals 2 that you just worked really hard to get. We're going to plug that in. We're going to say 3 times 2 plus y equals 9. Now do a little bit of basic math. 3 times 2 is 6. 6 plus y equals 9. We got to get rid of a positive 6 by subtracting 6 from both sides. So we're going to subtract 6 from both sides, and y equals 3. So our solution set, we use braces. They're a fancy little wiggly thing. You can do a brace by making an S and a backwards S. Okay, that's the left side. You're going to write 2, 3, and then a backwards S and a forwards S for another brace. And that's just the solution set. We had x equals 2, y equals 3. We're not writing them in x, y order. We're writing them in numerical order. 2, 3, because it's a solution set. Solution, I'm writing that out for you, solution set. Now, to be a really good algebra student, take the 2 and the 3 and plug it back in to that second equation and make sure it works. We know it works, or excuse me, we did the second equation. Plug it back into the first one. We know it works for the second one because we just did it to find y. But let's plug it back into the first one and make sure we did this right. So, got to get another board. You're like, oh my goodness, I'm using so much paper for these, and that's what happens. 5x minus 2y, does that equal 4? Or that equals 4. So our solution set, the x was 2, so we're going to say 5 times 2 minus 2, and our y was a 3, 2 times 3. Does that equal, I'm putting a question mark over my equals, does that equal 4? Because we're checking it. So 5 times 2 is 10, minus 2 times 3 is 6. Does that equal 4? 10 minus 6 is 4. Yay! 4 equals 4. We did it right. So our solution set that works for that equation that we had to find the y for, now we plug it back in and it certainly works for the other one. So we found the solution to that original 5x minus 2y equals 4 and 3x plus y equals 9. Okay? Phew! A lot of work. Now, you kick it up a notch. Sometimes we have to multiply both equations by a number in order to annihilate one of them. So let's take a look at one that might happen that way. We have 3x minus 5y equals 7, and 5x minus 2y equals negative 1. So you look at that and you go, oh geez. So 3x to 5x, there's nothing super simple I could multiply those by to get them to zero out right away. The negative 5y then, oh geez. Okay, now we got to think about what would I like to annihilate and how would I build them up so that I could. So I'm just going to focus on the x's because there they are right there, right in the front. So if I multiply by a 5, I would get 15 on my top one, wouldn't I? And if I multiplied by a 3 on my second equation, I would get 15, right? So 15 and 15, aha, I could do something with that and get them to annihilate each other. But 15 and 15, if I added those together, that would be 30. Oops. So then we got to think one step further. We like negatives, right? Negatives and positives, they annihilate each other. So what we could do is multiply the top by a negative 5 and the bottom by our positive 3. Because then we're playing, it's like a big puzzle. We're playing a game, annihilation. If we go negative 5 times 3x, we get negative 15x. If we go positive 3 times 5x, we get 15x. There's the annihilation. Negative 15, positive 15. So we got to do some work with both of them. So we're going to multiply a negative 5 times everything on the first equation and rewrite it. So you got to be really careful with your positive negative rules. Negative 5 times positive 3x would become 15x. Negative 15x. Negative 15x. Whew, I almost missed my negative rules. All right, negative 5 times minus 5x, y, negative 5y would be positive 25y, right? A negative times a negative is positive. Remember to look at that minus 5y as a negative. And that equals negative 5 times positive 7 is a negative 35. So we just built up that first equation by a power of negative 5. No big deal. Factor negative 5, it's built up. Now we're going to do a build up on our second equation. We're going to use positive 3 because we figured out we wanted this to be a positive 15x to get annihilated with the negative 15x. So 3 times 5x is 15x. 3 times minus 2y is minus 6y. And 3 times negative 1 is negative 3. Did I do my math right? 15x, negative 6y, negative 3. Okay, now, cover that up, get rid of it, don't look at it, it's kind of messy. Draw a line under the two build-up equations that you just made, and let's do some combining of these. We're going to add them together because we want that negative 15x and 15x to annihilate, right? To eliminate themselves. So they do, don't they? They become a 0, right? That's what we want. So then 25y plus negative 6y, that is 19y, isn't it? We got 25 positives, 6 negatives. 1 for 1, a positive and a negative cancel each other out, and we're left with 19 positive y's equals negative 35 and negative 3 is negative 38. Whew. This is a nice worksheet, isn't it? A nice problem, because that's going to be nice to divide by 19. You might not think so, but think about money. 19 and $19 is $38, isn't it? So if we divide by 19 to get our y, we're going to get negative 38 divided by 19 is negative 2. Oh my goodness. That was a lot of work. And guess what? We're not done. Now, we got to take this y equals negative 2 and plug it back in to one of the equations to figure out x. Either one probably doesn't really matter because they both got some things going on. But go back to one of the originals. Instead of the 15x, it's much nicer to multiply when we've got a 3x and a negative 5y. So I'm just going to pick the first one. I'll erase that last equation there from our last one. So we have that 3x minus 5y equals 7. And I'm going to plug in my negative 2. So I got 3x minus 5 times negative 2 equals 7. We've got to be very careful with our negatives here. We're going to get 3x minus a negative 10, right? 5 times negative 2 is negative 10 equals 7. Now when we have a minus negative, that means no negative, right? So that's actually 3x plus 10 equals 7, right? I hope minus minus means no, which means positive. So we now have 3x plus 10 equals 7. Now you got to do the old two-step solve an equation process. We're going to subtract 10 from both sides to eliminate that positive 10. We're going to get 3x equals 7 minus 10 is negative 3. And we're going to divide by a 3 on both sides, and x equals negative 1. Whew! There it is. X equals negative 1, y equals negative 2. Now one more good mathematical step. Our solution set, got that open brace, negative 1, negative 2. I put them this time in our XY order. That's okay. If we plug it into our second equation to make sure it works, so that was that 5x minus 2y equals negative 1. 5x minus 2y equals negative 1. We're going to hope we get it right. We better. That means we did it right. So 5 times negative 1 minus 2 times negative 2 Does that equal -1? Fancy little question mark over your equals. Does that equal? So 5 times -1 is -5, minus 2 times -2 is -4. Does that equal -1? Now remember, minus negative means no negative, so this actually means -5 plus 4. Does that equal -1? It does. Sweet, we did it right. Bing. Our solution to that system, originally 3x minus 5y equals 7 and 5x minus 2y equals -1, is -1, -2. You had to do multiplication times both of your equations to do the elimination. Takes a lot of time and a lot of work and a lot of paper, but if you just take your time and really think about what am I trying to do and kind of get mean with it, I'm annihilating these things. How am I going to annihilate them? And then follow it through and remember all your positive, negative rules, your two-step solutions to solving your algebraic equations. You'll finally end up getting that solution set. Remember to check it. Okay, check marks are good in math. When we check it, that means it checked and we did it right. Okay, so that is solving systems of equations by using multiplication to do the elimination, that annihilation. And then you substitute back in the variable, the one you found, and get the other one, and then you check it. All right, I hope this helps. Good luck. Work hard. Math's hard. You'll be okay.